Okay, sorry about the delay. Welcome everybody. My name is Meg Ray, and today I'm talking about teaching Python to middle schoolers. My background is in education. I was a special ed teacher for many years, and then I became a computer science teacher. And now I actually write curriculum for teaching Python to middle schoolers specifically. So this journey started in the 90s when I was super into science in middle school. I babysat my way to space camp, and I went to a science camp with my hero, astronaut Mae Jemison, and I was all set to become an aerospace engineer. I was really into engineering, and with all that passion, I became a theater major. So I ended up being an actor, a stage actor for many years, finding my way into education. And the fact that I opted out of my passion is a great regret in my life. And so it's wonderful that I'm now able to circle back and train in computer science and teach students. And part of my mission is that they themselves do not opt out like I did. So let's look. Oh, and in college, my dad was like, at least just minor in computer science. He's a programmer. He wanted someone to follow in his footsteps. And I was like, it's just not for me. Before I took a single class, I was like, it's boring. So why do students opt out of programming? Well, let's first look at the numbers. Who is programming? Who's not? So according to the annual, sorry, let me find the report. According to the annual Talby survey, which has been going on for 44 years, these are the stats for 2014 recipients of bachelor's degrees in computer science. 14.7% of recipients were women. And if you look at the racial gap, it's even bigger. So only 4.1% of recipients nationwide were black, identified as black or African American, and 7.7% identified as Hispanic. And this is reflected in the industry. There's recently an article out in the New York Times about how self-critical Silicon Valley is about their diversity numbers, but how they're still not changing. So we see at Facebook, only 2% of employees identify as black and 4% as Hispanic, and it's similar at Google and other industry leaders. And unfortunately, this gap is reflected in the middle school classroom as well, as far as who is learning computer science and who's not. So a lot of times we think it's as simple as people saying, well, I'm not interested in being a programmer, that's not for me. But it's much more complex than that, okay? The study of computer science education shows how access denied combined with belief systems that rationalize the lack of access translate to inequalities in knowledge, interest, and ultimately participation. This is from a major research study done in 2008 through MIT. The study was published as a book called Stuck in the Shallow End, and it really examines all of the factors that go into the systemic gap that's going on. So some things that contribute to this gap are poorly trained teachers, low quality curriculum in secondary school, lack of student guidance, so guidance counselors not pushing students that way, high stakes testing, the fact that low income schools are much more likely to offer high schoolers a class in how to use Microsoft Word, and higher income private schools or suburban public schools are more likely to offer CSAP classes. In addition to that, there's low expectations, tracking, labeling of students. Then students being behind in math and reading skills that they need to use text-based languages. And the list just goes on from there. So, because of this, I believe it's important that every student learn text-based programming in the school day, during the regular school day, not an after-school program. So, the reason I believe this is because it gives every student an opportunity to experience it and say either I like it or I don't like it. It's not a teacher saying, oh, this is a smart kid, they should take the class. It's every kid having the experience and deciding for themselves. It also teaches students how to think, so our goal is not for every single student to become a programmer, but our goal is for every single student to become a deep thinker. And then it's also important to understand the basics of how our world works. I've had so many students sit down, and it's like their first tutorial on Code Academy of HTML, and they're like, I'm hacking, look at me, oh my God, I'm hacking. Because they have no idea what this strange world of coding and programming is, and they don't really know what it does, and those are really important foundational understandings. So what does a classroom look like? Well, my middle school classrooms that I taught looked like this. They were diverse in all these different ways and more ways. Diverse languages, genders, interests, racial and ethnic identities, learning abilities, learning styles, neurodiversity, and I'll talk a lot about special ed as well, since that's my background. So, everybody says coding, coding, coding in middle school. All the middle schools do Hour of Code. What's stopping them from having classes in text-based languages? It's not lack of funding or lack of technology. They're very generous companies that will give schools technology. Even low-income schools can, if they're motivated to find the money, can have the money for a one-to-one laptop program. It's not lack of educational tools. There's a really thriving ed tech industry, and it's definitely not lack of interest. In 2009, Congress actually agreed on something, and that was that computer science education should be a priority in secondary school, but it's not happening yet. So, why is it not happening? Well, first, it's not on the test. As a former teacher, I can tell you that test scores drive what happens during the school day because they drive funding for the school. They control whether the school exists or not, whether the administrators and teachers have jobs the next year. So because tests are so high stakes, anything that's on the test is what the school day gets spent on. Also, teachers don't know how to do it. If there's no one that knows how to program, who's going to teach it, right? It's really hard to find quality curriculum. There's lots of tutorials and things online, but how do you kind of put that in the classroom? And also, adults are really scared of giving kids access to the internet, unfortunately. So, okay, so what is a quality curriculum? I keep saying, going back to this. So I'm going to talk about what works as far as a quality curriculum and getting programming actually into a middle school. So the first thing is to empower teachers. Let's be realistic. If you are a programmer, unless many, many programmers want to give up their job to spend it with to spend their day with mobs of tweens, and also take at least a 50% pay cut, we're probably not going to have experts or content experts teaching these classes. So what we really need to do is find the teachers who are willing and find ways to train them and support them. We also need to let go of how Python is supposed to be taught. So you probably learned Python in a certain way, and it was good for developing your idea, your understanding of how all the concepts work, and your ability to write a really good program. Those things are still important, but we have to keep in mind developmental cognitive ability right now. So at 11 years of age, it's different for every kid, students start to move into what's called the formal operational stage of development. What that means is, for the first time, they are just learning how to think abstractly, how to use metacognition, and how to problem solve. So if you think about 11 through 15, it's not that they get to 11 and get that skill. It's that 11 to 15, they're learning how to do those things. So we have to teach Python in a way that will work for students who are just learning what it means to think abstractly. On the other hand, a lot of teachers just stay with block-based coding, which I love block-based coding. I think it's a really good innovation in education for starting to get kids involved. But it just stops there so often, and teachers are really scared to move kids beyond it because syntax is really scary. And so there's sort of this balance between the tradition of very good programming education and just motivating kids and making it fun. So you can't have it 100% both ways. You have to find a balance. Yes, that's Scratch. So it's really important to examine, how do we build a conceptual bridge between things like Scratch to something like Python? How do we move kids in that direction? Text-based coding is really important. If a student ever wants to take a high school AP class, they will not be ready if all they've done is Scratch. If they get to college and they take CS 101, they won't be ready. If they are just interested in contributing to their community, creating something, putting something out there, the tools that are out there aren't generally block-based. So text is important. We just have to show kids the way. So what does this actually look like? These are a lot of ideas. What's it look like? This is my former 9th grade classroom. In this classroom, every student can see themselves. So when I put posters up on the wall, when I show videos, when I have guest speakers, I keep in mind, even if it's kind of surfacey, I want every single student to see themselves reflected in one of our speakers that year, to see themselves reflected on the walls. So I make sure to represent different genders. I make sure to represent all sorts of racial and ethnic backgrounds, and other things too, especially different abilities. I taught a mixed class of special ed and general ed. So it's really important that students see people with a diversity of abilities coding as well. The other thing is they should be motivated by the projects that they do. A lot of Python beginning learning projects are very math-oriented, and if students don't identify with math or like math, then they're lost right away. But you can tie in both math and creative writing and ELA and make sure that different subjects are integrated so that students with different interests all have an entry point. My philosophy was learn every way. So we're not just typing and seeing print in a console. They're touching code, they're writing code, they're moving it around, they're mapping it out. This is a map of a text-based adventure game. They went back, this is the story part, they went back and added the code onto this paper map before they went into their program. This way they can play with the organization and what gets written first and second versus where it's going to go in the program. They can move it around, they can make mistakes. When they learn really basic commands, I had cards, like cutout cards, and they would have a little card deck and have to follow the commands and actually act them out, move with their bodies. Or they would have beans that they would put down, and then I'd write a little program that would do the exact same thing, and they could test out what they did with their body in the program if they put the commands in the correct order. So it's really important for kids to have every kind of connection that they can to the concepts. Problem solving is a skill to be learned and practiced. So it's really scary for kids to get an error message. We had to just practice that it's okay to get an error message. And we don't have to freak out. And then learning how to read the error message, and then learning how to use it. I also, let's see if it's on this side. Yes. Also just teaching them the process of problem solving. So this is like the very beginning of the year when we're first learning problem solving, and they had to do flowcharts. What's the problem? How do you get to the solution? And it was a really big deal. It was a big stretch to do. And then here, by the end of the year, this was just for a short project where they designed a physical game, and they were just voluntarily getting up and planning and using trial and error and recording their results. In education, we use a term called blended learning. It's just kind of the trendy catchword right now. I like to call it the startup classroom. So the kids have different tasks. They have to complete lessons where they're learning concepts. They have to complete practice drills, like they need to practice the concepts. They need to do group projects. They need to do individual projects. There's all sorts of different things happening, and they're happening at different times and at different paces in the classroom. So the classroom is actually set up to promote that. There's different areas to do different types of work. And in order to do that, oh, here's an example. In order to do that well, it's really important for middle schoolers to have procedures and routines. This is true of both the classroom and like hackathons or coding events for kids. Kids need the structure and the guidance. So if you're doing a project, how do you set a goal? How do you break it down? What comes next? So you can only have this sort of fun, asynchronous chaos if you also have the routines and procedures to back it up and to help kids to handle it. I also did a thing called Unit 0. A big barrier in middle school is that we assume kids know how to type because they can text really fast, and they can't type, and they're not getting any typing classes. So imagine sitting down and trying to write a program when you're typing like this. So it's pretty slow, huh? So kids also, like most of my students had never used a keyboard shortcut, and that can save a lot of pain. Really basic things like that. We had to step back and learn some of like, how do I do things that I need to do in order to program? And we call that Unit 0. I put a lot of video tutorials up on a website so that kids, we didn't have to stop the class to do it. Kids could just go access it as wherever their gaps were. So syntax, that's the biggest barrier, especially for students who are behind in reading and writing. And for students with learning disabilities, especially if they have dysgraphia or dyslexia, but they can still do it. The trick is that you need to create more success with syntax at the beginning than frustration. There can be some frustration, but you can't let the frustration level rise until they've built up a little bit of resilience. So there's lots of solutions to this. You can start with templates that you write and the kids edit. You can have cheat sheets and cards that they can have to access and guide them. At the company I work for now, we have a toolkit that is a transition between blocks and text. So you drag a block in and you're actually dragging in the full line of text. But at the same time, it's important to not stay there. So once you've built up that ability to deal with the syntax, the familiarity, then you do need to circle back and get to that and have students learn that. They just need to build up the tolerance for it first. And that brings us to building resiliency. This is the hardest and most important part. At least in the public schools that I worked in, kids were not used to having to problem solve and think systemically on this level. There's always a right answer. They wanted to know, what's the right answer? How do I do this exactly? And a lot of times, especially as I was starting out and I was still learning Python, I had to model for them, I don't know, let's learn together. Here's how I look it up. Here's how I do this. Here's what I'm going to try. And I would model my learning process for them. For middle schoolers, that blew their minds. It's a little scary. Also, like I went over with them, I'd say, Google it. And they would say, that's cheating. So we had to really focus on the difference between, okay, what's cheating, what's copying something from a website, and what's using a resource. Or what's copying work from another student and what's working as a team. And middle schoolers, I mean, that's the time when you figure those things out. And this computer science class is a great place to do that and figure those things out. I found that the skills that my students learned in this class translated to all their other classes because it became the place where they were learning core academic skills as well. And once they were able to once they wrote a program, their final project was very simple. They wrote a very simple choose your own adventure game. And once they did that, they were blown away. They were so empowered because it was something that they never thought they could do. They looked at those lines of text on the first day and their eyes glazed over and they were like, that's whoa, I can't do that, you know? And a lot of the adults in their life were saying the same thing. I heard so many times, like, just teach Scratch, just stick with Scratch. It's easier, it's for all the students. You have all the students, they'll all be able to get Scratch. Well, this particular class was in 9th grade, and I didn't think that was fair to them. So I taught this class, and they were very empowered by it. So here's an example. One of their programs, we used a platform called Trinket, which is an online, it's a free online platform for schools to use. So we use Trinket. It's all in the cloud, which is very important for middle school because they don't have their own computer. This particular project, and then they presented at a citywide event. There they are, presenting their work, teaching kids how to play their game. This particular group of students, it was 4 students. One student had a learning disability, one student was on the autism spectrum, one student was just learning English for the 2nd year, and one student was categorized as gifted. And the 4 of them, I work closely with their groups, so I know that all 4 of them contributed equally. And I was just very impressed by what they can do. With Python, when a lot of adults were saying, don't teach this, it's not even worth it. So with all this information, what can somebody who's in the tech industry but not in education do? Well, and I want to share what I'm doing too. Right now, I am actually developing a middle school curriculum for Python. It's called Codesters, and like I said, we have a toolkit where they drag the block, but it actually turns into code, and then they can switch back and forth between typing and dragging. And then we also integrate with JavaScript using Sculpt, so that kids have that visual feedback. And so what I do right now is I write the curriculum and I help train teachers to use it, and I go into classrooms and I help kids use it in classrooms. Short of doing something like that. You could program a platform or tool. You can start or contribute to open source projects. The biggest needs right now are really documentation. I know that's kind of boring, but I had so many students that were learning English, and it would have helped so much to have documentation in their own language. It's really hard to find. You can find it, but a lot of it's written for programmers, so it's hard to read. And so going off of that, documentation written at a middle school reading level. I would not, that's, I guess a big thing that contributed to me learning Python quickly was that I had to rewrite documentation and translate it for middle schoolers. Kid-friendly error messages. I cannot say how discouraging an error message is for a student, and they get so many of them right away because it's just very difficult. And having some sort of option for kid-friendly messaging is really important. And then, like I said, open source projects like PyPy.js and Sculpt allow people to develop platforms like Codesters where kids can get the visual feedback. You can also actually work with kids if you're interested. A big thing when I was a teacher was people who were willing to come into the classroom and be guest speakers, and people who were willing to host us either on a Google Hangout or actually have kids come to their office. It made a huge difference. It made it very real for kids to be able to see someone in their office and see what the day's like, and it helped break down that stereotype that they have in their head of what a programmer is. There are lots of educational events, like hackathons, Coder Dojo, things like that, where you can volunteer as a mentor at the event. And that makes a huge impact on kids because they can't just go to a hackathon and start working. They really need the guidance from someone who knows what they're doing. And like I said, their teacher may be learning with them. So it might be their only chance to learn from someone who is actually a content expert. Another thing you can do is teach a teacher to code. So I could not have started teaching computer science. None of my former students would have gotten a computer science class because there was literally no one to teach it until someone taught me code. My husband taught me code. But that's a very important thing. So that is my presentation. Oh, I was going to say that, so now 13 years after my dad told me to at least minor in computer science, well, I've come full circle, and I'm actually working in computer science now, hopefully more and more, continuing to learn. So you just had to be a little patient. And hopefully this time I'm bringing lots of students with me who will stay with it. So that's it. You can find me at Twitter and email me and on LinkedIn, and I'll open it up for questions. Yes? Awesome. Mm-hmm. Mm-hmm. It is, yeah. You can email me. It is the platform is free to use, but the curriculum is paid. So just email me, and we could talk about the free and paid options. Yeah. Yes. Sure. I can't talk too much about them, but so they're both open source projects that allow you to program in Python and see illustrations, animations of the results because they're built on a JavaScript. They're integrated with JavaScript. That's all I can tell you. It is, yeah. It's open source. It's free. It's free to use and contribute to. Our our designers, our programmers at Codesters contribute to it and use it, and so it's open for anyone to use. And it's great if you're interested in finding something to contribute to. It's great because anybody can go on there and do something similar. So, yeah. Mm-hmm. Well, I think math is very important as well. Don't want to sacrifice math for this, but I think it's really important because at this age, middle school to early high school, kids start getting tracked. And their classes, especially as they get through high school, start becoming more and more out of their control because they have to meet graduation requirements, and they're getting pushed into either humanities and arts type classes or math and science type classes. A lot of the kids I know, I mean, there's really gaps and deficits in teaching math as well. And kids aren't necessarily, at least in urban schools, getting the greatest math education, so they're not really interested in it. This is a great way to interest kids in it. And also I think the text is important because starting in middle school, a lot of them have done Scratch in 4th and 5th grade or younger even, and they've done Scratch in middle school, and they're really good at picking it up and mastering it, and they do get the concepts, but then it kind of stops there and they don't connect it. They don't independently make that connection to this is what programming is, this is what computer science is, because it seems like a game. And you have to actually show them, guide them to those connections. And having the real world text language is also meaningful because it makes them feel like, oh, I'm doing a real thing. It's really important. And they're getting to that age where that's, how do I use this? Why is this important? This is a waste of my time. Those kind of questions become really important. Mm-hmm. That's true. And I think especially before I was teaching middle school, I was working with older students who were behind in credits, and that aspect becomes much, much more important as kids get older. Yeah. Mm-hmm. 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 Yeah. Mm-hmm. Yeah. Mm-hmm. Yeah. Mm-hmm. Yeah. Yeah. Mm-hmm. Mm-hmm. Well, the adult learners that engage the platform are the teachers. So in general, what happens, there are some exceptions. There are a handful of great computer science teachers at the high school level in New York City, but they're very rare. Um, so the majority of the time, it's a teacher who's saying, I'm willing, I'm scared, but I'm willing. And they will use the platform first. They'll go through the curriculum first and learn Python in order to teach it with the same platform. So it's also how they're trained. I don't think adults, just in general, have been using it. I mean, they definitely could. But I find that the teachers usually pick up the concepts really quickly. The kids seem to pick up how the platform works quickly. Like, they figure out what all the buttons do. They figure out how to make things happen quicker than the teachers do. but the teachers really get the concepts from it, and that's the important part, because that's key. The kids can't just go through it. Like if they're just doing, I had my kids sit down and do Code Academy and go through it, but they were like, I don't know, I just followed the directions. That's all, I just followed, I couldn't do it again. So it's really important to have that missing piece of the teacher in there to help them retain and apply the concepts. So I don't know if that answers your question, but yeah. Yes, yep, yeah. Honestly, this is hard for me because I feel like it's not ideal, but it's how it is right now. It takes, like a week or a few hours on there because the teachers don't have time to stop and take a class. What they're doing is they're going through one day, it's like midnight, and they've gotten all their grading done, and they're like, okay, I think I can stay up long enough to do the next Codesters lesson for tomorrow. And that's what they're doing. Yeah. Yeah. And we go in, and that's part of what I do, is I work in the classroom too. When I taught computer science and learned it, I didn't use Codesters, but it took me about a year. The first year was just a shit show. I'll just admit it. And yes, that's very true. Here's my resource. It'd be the middle of the school day, and I'd be like, okay, save my face right now, because I'm trying to say I know how to do this. But yeah, even though I was like learning, and I would learn a little ahead, and I could teach the concepts I had learned, it did take that year to kind of put all the pieces together to be able to have something more coherent for the kids. So I think that's a good assessment of the year. Yeah. Yeah. Yes. Yeah. It is very difficult. And so imagine, like, okay, if I'm college age or above, I'm maybe in my 20s or 30s learning Python. Well, there's a lot of jargon. It can be kind of frustrating to use the documentation. Now imagine if your reading level is between like a 4th and 6th grade reading level. You don't have very much vocabulary to draw on. So it's sort of amplified. So there's different movements. There's none. So the state right now doesn't, New York State doesn't even have a certification for teaching computer science. You can get a educational technology certification, but that's like teaching kids Word and typing. There's no certification, let alone standards. There are some independent standards being put out. CSTA, which is Computer Science Teachers Association, is a small independent organization that put out a set of standards. Companies like Scratch will often put out standards. There's a new AP course out. I want to call it the Joy. Thank you, Beauty and Joy of Computing. I'm sure they have some kind of standards that go with that, but there's nothing that's commonly accepted. Yeah, and it's actually both. I mean, they might already be teaching it, but it was because they were repurposed. Right now, the people teaching it are the most willing. They're that one person that is not afraid to make a PowerPoint. And so their principal's like, oh my God, you're computering, you could teach this. And a lot of times they're already in the classroom and they're like, what do I do now? So yes, they're usually repurposed, and they're from math or science, and they're usually already teaching. Like I said, there are a handful of amazing trained computer science teachers at the high school level in New York, and I'm not doing any training for them because they know way more than me. So, yeah. I'm not. I'm aware of their curriculum, their curricula, though. Australia has a platform called Grok, and I actually just met the developers, which is another online platform for learning Python. And in the UK, there are several curricula that have been adapted pretty widely. And I actually like, I wish I remembered the name of one of them. There's one of them that I really, really like, but I haven't seen a lot of schools using it here. So, yeah. Mm-hmm. Yeah. Yes. Yes. Yeah. And unfortunately, at the middle school level, that's really how much you have to know to be qualified. And that's why it's so important to find those teachers and get them trained because they are willing. They have no starting point. So, yeah. So the most recent school I taught at was high school in the Bronx. Every single ninth grader was required to take a software engineering course, which was my course. And they use Python, and they also use HTML and CSS. After that, the school is based on apprenticeships. So in 10th grade, they can choose to take an elective. And then in 11th and 12th grade, they can major. That's one of the majors that they can pick of 4. And if they pick that major, they're supposed to find an internship related to it. And then they get to take a more advanced class where the school contracts out somebody that's like a professional in the industry. Which, as far as high schools go in the Bronx, that is a very rare program. There's a handful out there. There's also the Bronx Academy for Software Engineering that has a great program too, but it's not widely available. Very low. So that's why I taught what I called the Unit 0. It was like the pre-unit. Because students had a hard time with typing. I was really surprised when they didn't know how to save things because everything gets automatically saved all the time on Google. So they would lose work because they forgot to hit save or they didn't know to hit save. They had never heard of shortcut keys. And things like Googling information and evaluating information. I actually had started trying to teach them how to find and evaluate sources on the internet, and then I realized this is a whole different class. This is going to take way too long. So I wasn't able to teach it because it really needed its own space. But I would say that whole range of skills, both in middle school and high school, is pretty lacking because there's not really a space to teach it. And kids actually have to, they're they're not just going to magically pick it up. That's not a fair expectation. So. Cool. Thank you.